Part two. So here we have just some, some reminders about picking out and realizing what the diagram shows, and then of course a little picture here. So let's get to it. So we want a set of two parallel constructors. Parallel, or you can tell by looking at these V's. And so here we definitely have one set of parallels. Here we see a single chevron, a single V, and so here we have a second. So we can definitely map out two real quick. Um, so two sets of parallels. Let's go red first. So I'm going to use AC. I'm going to call it a line segment because I definitely see that's what we have right here. That's going to be parallel to FE. I'm going to go ahead and call that FE ray. And so we have parallel to FE ray. All right. For the green, we have AJ. I'm going to call it a line. So AJ as a line. Okay, and then we have CE here, so CE as a segment. And again, proper notation is definitely needed here. So make sure that you're observing not only that the parallel symbol has to be there, but how to write the things on either side. Let's talk congruency. So congruency is set off by this symbol, and is shown by tick marks. So I need to set two sets of congruent constructors. And so we have to observe right away that we have one set here, which is good, and then we have another set here. So here's a 3 marker, and here's a 3 marker. There's actually another set here. This is kind of like a hidden one. But here we have a radius, and here we have a radius. So there's a third set as well. Now this third set doesn't actually have a point where it needs it. We're going to have to maybe just add a point here. I'm going to call it point X. And that's okay to add like points to our diagram to help us answer the question. And so even though it asks for 2, let's go ahead and write all 3. So the first one, we'll use like these 2 marks here. Now, even though these are part of bigger constructors, we have to remember that congruency can only occur in segments. The lines can't be congruent, either can rays. And so we want congruent constructors here. We have to limit ourselves to segments. And so we have HJ congruent to JG. And that'd be the purple set. Is that blue? Okay. So here, let's mark the 3 mark set. So here's a triple set, and here's a triple set. And so we have GD as a segment, of course, congruent to, we'll have AH. And then this last set, they're both radii, which is why they actually have to be congruent. But we do have another set right here, the BF, and then the FX. So BF is congruent to FX. Oops, like this. Hey, and so keep that in mind that you're not limited to, even though it says 2, you can obviously write 3, but sometimes you have to be more clever, like within the diagram to find those pieces. Let's move on to perpendicular. Okay, so perpendicular constructors mean they meet at right angles. I do have one right here, smack dab in the middle. I don't have any others. You might be tempted to call this perpendicular, but we don't know it's supposed to be. We don't know the intent. We don't know this to scale. If we don't know it's to scale, we have to rely on the marks. And all I see is one, I'm sorry, we have another set right here. All I said are those 2 sets right there for perpendicularity. Now perpendicularity can be any type of constructor, so these could be rays or segments or whatever. And so let's mark this first set. I have AC on top, so AC on top, perpendicular to BF. And AC, I'm going to go ahead and call a line, I think. No, I'm going to call it a ray. So ray starts A, runs through C. They are going to be perpendicular. And then we have BF again, so it's actually the same exact one. Perpendicular now to FE. And so we have F to E as a ray. Okay. Now, naming 2 angles that aren't right, well, literally any angle but the 2 I just named are going to be fair game. So I'm not going to make a whole comprehensive list, but just make sure, like when you're naming angles, you start off with the angle symbol, and then you have 3 letters, and the only important one is actually the middle. Just make sure that's at a vertex or a vertex to your corner. Okay. So let's sketch a single diagram with the following directions. And so this is one where you have to kind of progressively add to your diagram, but let's get to it. The first thing is AB as a line, and that's important that we observe that it has to be a line here. Pick a point C, then sketch BC as a segment. such that it's not perpendicular to the original. So in other words, it can't be right. And so really the only place I can't put C is like directly above or below B. But I'm going to offset it here, so I'm going to call this C. But we have to notice here that these do have to be congruent. BC is to AB, and now this is technical difficulty, but this should really be a segment AB. So even though it's drawn as a line, we have to kind of consider that just as a segment piece of that, which is okay to do because we know that the definition of a line is set of collinear points, and we can take that to be as long as we want. Now, since it is congruent, we do have to mark these congruent, and so there we go. So it's not perpendicular. In other words, it's not a right angle, but they are the same length. Let's talk about D. So pick a point D to sketch a line DC. So it's not perpendicular. DC is not perpendicular to BC, so it can't be perpendicular to our kind of darker line here, but the lengths have to be the same. And so about right here, I think is appropriate for that letter. And so it cannot be perpendicular, which it's not, but it does have to be the same length. And so even though that's an equality here, equality implies congruency, and so we can definitely mark that as such. The sketch AD such that it's not perpendicular, but it's parallel. And so this is really just kind of a finishing line here. If we positioned everything correctly, that's exactly what AD should be. It's not perpendicular, which it's not, but it should be parallel to BC. And so let's go ahead and mark that. Now we could argue that it should be congruent also, but since the diagram is not asking for that, that's as far as we can take it. And so as far as checking this, I'm going to be checking two different things. The first thing is going to be, are all the structures right? In other words, do you have like the lines where it says lines, segments where it says segments? But I'm also going to check for these relationship symbols. So there should be one parallel marking, there should be two congruency markings, and that's what we have in our diagram, so that's good to go. All right, so we'll stop that here for part 2. I'll see you guys in part 3.